We start this problem once more by factoring out the denominator. So factoring out the denominator gives us the following expression. If you notice, our factor x minus 2 appears twice. That's x minus 2 times another x minus 2 times x plus 4. If your factors are repeating, we now have the following solution for that one. So decomposing this integrand into its partial fractions, we now get this. If you notice, the second x minus 2 term over here is raised to the power of 2, while the first x minus 2 term remains as it is. And with that, we're able to multiply both sides by the denominator x minus 2 times x minus 2 times x plus 4, so that on the left side, no denominator remains. And as for the right side, you now have the following. So the x minus 2 term here cancels out the x minus 2 being multiplied through all of these to give you a times x minus 2 times x plus 4. As for the b term, you have x minus 2 squared cancel out these two, leaving you only with x plus 4. And lastly, for the k term is now multiplied by x minus 2 squared. So once more, we assign values of x so that one or more terms will disappear, leaving us only with one term whose value could be already solved. So let's say we assign x now equal to 2. When x is equals to 2, this term over here becomes 0, so the a term disappears, and as well the k term disappears as well, since this also becomes 0. So with that, we can solve for the b as follows. Letting x equals to 2 now, we have this expression. This one disappears, this one as well, leaving us with 4 minus 7 equals to b times 6, or b is now equal to negative 1/2. Assigning yet another value of u, this time we now let x be equal to negative 4. In that way, the a term over here disappears because this one becomes 0. And as well, the b term vanishes as well. So assigning now x equal to negative 4, you'll get this expression. The a term will disappear, the b term as well, leaving us with the value of k. So for k, you now get k equals to 1/4. At this point, we've exhausted all values of x for which one or more terms in this expression will disappear. So let's just assign a value of x at random. So personally, I prefer to use x equals to 0 if it's not assigned yet. That way we don't have so much computation left to do. So letting x now be equal to 0. If your x is now equals to 0, you now have the following. So once more, we replace all of the b expressions in here with the negative 1/2, like in this part. And since we've solved for the k as well already, we also use this value as well. So your b here is the negative 1/2, and the k is equal to 1/4. So solving this now to get the value of a, we have a is equals to 3/4. Now that all the values of our constants are computed for a, b, and k, we can now replace or we can now integrate our partial fractions as follows. So with these three partial fractions, which are easier to deal with, our integral is now equal to the following.